All right, students, in this video, I'm going to go over the notes of how to solve systems of linear inequalities and by graphing. So first, we need to understand what a system of inequalities is. It's whenever you have two lines graphed, but also with a shaded area of solutions. And then also the lines have to either be solid or dashed. So these symbols replace the equal sign in an inequality. And you have to decide when is it solid, when is it dashed, and when is it shaded above or below the line. So this graph, this table right here shows you the shortcut of when is which. So we decided to conclude that the solid lines happen whenever you have the equal to signs. So you're just gonna like have points plotted, and then you're just gonna have a traced solid line from one point to another. You're just gonna trace a solid. If it's dashed from one point to another, you're just gonna draw some dashes representing a dashed line between those points. Okay, and then besides dashed or solid, you have to decide whether to shade above or below. So we concluded that if you have y by itself on the left side and mx plus b format on the right side, or you can even have x, but we'll get to that in a little bit. So whenever you have a y by itself on the left side, you want to conclude whether you are shading above or below the y axis, like on a point, like on the y-axis. So if it's greater than, you want to go above because the y values greater than that point right there are above. And then if it's less than, you want to shade below that point. So I'll do a couple examples in a little bit. Before we do the graphing part though, I do want to point out we can check for solutions without having to graph. We can just substitute the values given into each inequality, and then we just want to check if it's a true or false statement. If it is true for both of the inequalities, then it's a solution. So here's an example. This is a x, y ordered pair, and we're going to substitute those values for the x and the y's right here. So 2x plus 3y less than or equal to 6. We're going to substitute the x with a negative 2, a y with a positive 3. 2 times negative 2 is negative 4. 3 times 3 is 9. And if we add negative 4 plus 9 is 5. So 5 is less than or equal to 6. Again, that's a statement for you to decide if it's true or false. That is true. It's less than. And now we check for the other one. We have y greater than 4x minus 1. Y is 3. 4 times negative 2 minus 1. 4 times negative 2 is negative 8. And then negative 8 minus 1 is negative 9. So 3 greater than negative 9, that is also true. And because both of these are true, that means that this pair is a solution to the system. So yes, it's a solution to the system. Whenever one of these is false, then no, that is not a solution to the system. So you have to check for solutions in an inequality like this, or also from a graph. So we're going to go ahead and follow these steps to graph inequalities from scratch. And then this is your go-to to refer to for reference. All right, I'm only going to do the problems on the left side as examples for you to practice the ones on the right side. Okay, so the first one here is, I consider it level 1 because the inequalities are given to you already in the format of mx plus b. And when they're already y equals mx plus b form, you just gotta plot the points and shade. So the first one, I'm gonna color coordinate. You wanna start with the b value, that is your y-intercept. So for example here, the b value is negative 2. So your y-intercept is negative 2. And after plotting that point, you're gonna move like your slope. The slope is right here, negative 1. There's an invisible 1 right there. So if your slope is negative 1 and you need to move following the rise over run ratio, you gotta make this a fraction. So negative 1 over 1 is your fraction for the slope. That means you're gonna rise negative 1. We're gonna go down 1 and then run 1. Down 1, run 1. So you just follow that pattern and then go backwards if you run out of space. So up 1, left 1. And once you complete the points that could be plotted, then now you need to decide what is that symbol telling you. Is it dashed or solid? So because it's equal to, we're going to say that it's a solid line. We're going to draw a solid line through the points. And then less than or greater than, that is a less than, which means that you're going to shade below this line. So ideally, I want you to focus on the y-intercept and then below. So that means we're going to shade below. Okay. Next, let's graph the other one, repeating the same steps. We're going to start with the y-intercept, the b-value, which is positive 1. We're going to move following the slope, which is 1 over 2. So rise 1, run 2. Rise 1, run 2. Run out of space, so go backwards, down 1, left 2, down 1, left 2. Then you look at the symbol, if it's dashed or solid, so it's equal to, so it's going to be a solid. And then above or below, that is a greater than. So that's above. Above this point are the greater y values. So we shade above. Okay, so now that we shaded both parts, there is this area right here that it's double shaded. That is the set of solutions for the system that we just graphed. So this system is asking you, is 2, 3 a point that is a solution? So 2, 3 is over here. It is in the shaded area for the red one, but it's not for the other one. So no, it is not a solution because it is not in this double shaded area. Okay, let's move on to the next level. So the next level is this part where the inequalities are not written in mx plus b form. You need to rewrite them. So let's do that first. We're gonna keep the y, move the x, minus 2x, and then we're gonna divide by the number next to y, divide by negative 3, each part. This division cancels the 3's or eliminates the negative 3's in the front, and you just leave it with the y. We're dividing by a negative, so we're gonna have to flip the sign. And then these two, if you want to write it in the format of mx plus b, let's first focus on this one. Negative divided by negative is positive, 2/3. And then 7 divided by negative 3 is negative 7 divided by 3, 7/3. So this is the equation, or inequality, sorry, that we're going to graph for that one. For the next one, we get rid of the 5x, move it to the other side. And then we have to divide by the number next to y. So 3 divided by 3 is y by itself. We did not divide by a negative, so we keep the symbol. 0 divided by 3 is nothing. And then negative 5 divided by 3 is negative 5/3. And again, focus on writing that one first to follow the mx plus b. And then 0 divided by 3 is 0, but we can just leave it like that. We don't have to write plus 0. All right, so now let's graph. Negative 7/3. Negative 7/3 is not a whole number. It is a decimal. It's 2.33. So we're looking at negative 2.33, somewhere here, between negative 2 and negative 3. And then you rise over run, rise 2, run 3. Rise 2, run 3. Rise 2, run 3. Down 2, left 3. That is an inequality that is not equal to, so it's going to be a dashed line. And then it is a greater than, so greater than -2 is up here, so we're going to shade above. Next is this one, and again, there was no y-intercept, so we're going to start 0. -5/3 means we're going to go down 5 and across 3. Rise or run. If we go opposite, we'll go up, left, up, left. This is an equal to, so that means we are going to have a solid line. And then it is less than, so it is going to be less than 0, which is down here. So anything shaded below. So in this case, the double shaded area is this part right here. And the question is asking if 0, 0 is a solution. 0, 0 is right here. 0, 0 is almost part of the shaded area, but 0, 0 is in a solid line. So that is a yes, because it is in a solid line. It is considered an edge of double shaded. And on solid line. So if it was over here, it would be no, because it's not in the double shaded area edge per se. All right, last example is a system that has 3 inequalities. So this first one, it's going to be a vertical or horizontal line. So from Algebra 1, we had a shortcut called Hoy-Vux. The top Hoy represents horizontal lines, start with y equals, and then Vux represents vertical lines, start with x equals. But in inequalities, it's just like having x equals -1, we're just going to have an inequality. So that's a vertical line. We're going to graph a vertical line when x is -1 right here. And basically, these are the points that will be on that line. And we just decide if it's dashed or solid. So that symbol is dashed. So we're just going to have like a little dashed line going down or up. And then that symbol is greater. So x values that are greater than -1, if you're looking at this, the x values that are greater are on this side. So we're going to shade to the right. Okay, so the next we have y is greater than or equal to 3x. That has an x in there, so if it follows mx plus b, that x is this part, but there's no b, so that means the y-intercept is 0. And your slope is 3. So 3 over 1 will be your rise over run. Rise 3, run 1. Rise 3, run 1. Down 3 across 1, down 3 across 1. So then you have a solid line. And it's greater than. So if 0 is right here, values that are greater are up here. So we're going to shade this way. Okay, and then the last one, we have x plus 4y less than 8. We cannot graph it until it's in y equals mx plus b mode. So the x needs to be subtracted. So 4y less than -x plus 8, because that's a negative x and an 8. And divide by 4. So we're going to have y is less than, this is a 1, -1 divided by 4, so -1/4 x. 8 divided by 4 is 2. So we're graphing this line. +2 is your y-intercept. -1/4 is your rise over run. -1 down 1 across 4. And then up 1 and across 4. This inequality is not equal to, so it's dashed. And then is less than, so we're going to shade below. Okay, so I'm going to highlight the section that it's triple shaded, which is this part right here. This is where the solutions are at. And then we check if -3, 1 is a solution. So -3, 1 is right here. Definitely -3, 1 is not part of the triple shaded. So no, it is not a solution to the system. Not in the triple shaded region or area. Okay, and that's pretty much the basics of graphing inequalities to find solutions for them.